If adding fractions feels annoying, adding rational expressions probably feels impossible. Not anymore. Today, you'll learn how to simplify them quickly, step by step. So what are rational expressions? A rational expression is just a fraction with polynomials in the numerator and denominator. For example, 3 over x is an example of a rational expression, or x plus 1 over x squared minus 4 is another example, or x squared minus 1 over 2x plus 7 would be another example. Remember that whenever you have a rational expression, the denominator can never be 0, and you have to watch for factoring opportunities. And throughout this lesson, I'll be referring to LCD, and that stands for the least common denominator. So here are the key steps for adding or subtracting rational expressions. First, you want to factor all denominators. So you want to break down each denominator into its simplest factors to identify common elements. Then you want to find the least common denominator. Determine the least common denominator by identifying all unique factors. Third, you'll want to rewrite each fraction with the least common denominator. So you'll need to multiply numerator and denominator by missing factors to create equivalent fractions. Fourthly, you'll combine the numerators. You will add or subtract the numerators while keeping the common denominator. And then finally, you'll simplify. So you'll want to factor and cancel common terms if possible in order to reach the final answer. So here's our first example. We want to add 3 over x plus 5 over x. In this case, we have a common denominator, which is x. So we can simply add the numerators. So 3 plus 5 over x is simply 8 over x. So our answer is 8 over x. When the denominators are already the same, simply combine the numerators. Now, we want to compute this operation. X over x plus 2 minus 3 over x plus 2. If we're looking at our denominators, they are the same once again. So we can simply subtract the numerators directly. So our answer is x minus 3. We subtracted 3 from x, and our denominator is still x plus 2. So when denominators match, the operation becomes straightforward. Just subtract the numerators and keep the common denominator. Now here's our problem. X over x squared minus 9 plus 2 over x plus 3. Now we can clearly see that our denominators are not the same. So first, we'll need to factor the denominator. X squared minus 9 is a difference of squares, so this could be factored as x minus 3 times x plus 3. If we use the FOIL method to check it, x times x is x squared, x times 3 is 3x, minus 3 times x is minus 3x, so our two middle terms cancel out, and negative 3 times 3 is negative 9. So in this case, since I have x minus 3 and x plus 3 as my denominator for my first term, and x plus 3 as my denominator for my second term, the least common denominator is x minus 3 times x plus 3. So now we will rewrite each expression. My first term, x over x squared minus 9, can be rewritten as x over x minus 3 times x plus 3. We already figured out that this is x squared minus 9. Our second term, 2 over x plus 3, we will multiply the numerator and the denominator by x minus 3. So you can see here 2 times x minus 3, and now her denominator becomes x plus 3 times x minus 3. Now we have a common denominator for both terms. We can therefore combine the numerators. So our numerator will become x plus 2 times x minus 3, and all this over our least common denominator of x minus 3 times x plus 3. And if we distribute the 2, this becomes x plus 2 times x is 2x, and 2 times negative 3 is negative 6. So simplifying, we can combine the like terms. X plus 2x is 3x. So we have 3x minus 6 over x minus 3 times x plus 3. And we can furthermore simplify because we can factor out a 3 out of our numerator. So this becomes 3 times, open parenthesis, x minus 2, close parenthesis, over our common denominator of x minus 3 times x plus 3. If you like what you see so far, please like and subscribe to our channel. So let's look at another example. In this case, we have 2 over x plus 5 over x plus 1. So clearly, our denominators are different. So we'll need to find the least common denominator. In this case, it will be the product of the two denominators. So x times x plus 1. We can then rewrite our terms. So we'll multiply 2 over x by x plus 1 over x plus 1. That way, our denominator becomes x times x plus 1. And remember, if you multiply the numerator, you need to multiply the denominator by the same term in order for your expression to be equivalent. Similarly, for our second term, we multiply the numerator and the denominator by x. So it becomes 5 times x over x times x plus 1. Now we have a common denominator, which is x times x plus 1. We can therefore combine the numerators. So 2 times x plus 1 plus 5x. If we distribute the 2, 2 times x is 2x, 2 times 1 is 2, plus 5x. Combining like terms, 2x and 5x is 7x, so we get 7x plus 2. Our final answer is therefore 7x plus 2 over x times x plus 1. So once again, when denominators differ, multiply each term by the missing factors in order to create a common denominator. Now, we want to perform this operation. 3x minus 1 over x squared minus x minus 2x plus 5 over x squared minus 1. Clearly, our denominators are not the same, so we will factor first. X squared minus x could be factored out. X could be factored out, so this would become x times x minus 1. And for a second denominator of x squared minus 1, this is a difference of squares, so this could be factored as x minus 1 times x plus 1. So our least common denominator in this case would be x times x minus 1 times x plus 1. Now, we can rewrite our two terms using our least common denominator. So our first term, 3x minus 1 over x squared minus x, would need to be multiplied by x plus 1 in the numerator and x plus 1 in the denominator. Similarly, our second term, 2x plus 5 over x squared minus 1, will need to be multiplied by x in the numerator and x in the denominator as well. So now we have a common denominator, that is x times x minus 1 times x plus 1. Then we can expand our numerators. So here for our first term, we have 3x minus 1 times x plus 1. Using the FOIL method, 3x times x is 3x squared. 3x times 1 is 3x minus x would be 2x. And negative 1 times 1 is negative 1. So my numerator becomes 3x squared plus 2x minus 1. For my second term, if I expand, 2x times x is 2x squared, and 5 times x is 5x. So my numerator for my second term is 2x squared plus 5x. Now we can subtract 2x squared plus 5x from 3x squared plus 2x minus 1. So 3x squared minus 2x squared is x squared. 2x minus 5x is negative 3x, and negative 1 remains negative 1. So our final answer is therefore x squared minus 3x minus 1 over our common denominator of x times x minus 1 times x plus 1. So here are the common mistakes to avoid. Forgetting to factor first. Always factor denominators completely before in order to find the least common denominator. Another common mistake is only multiplying part of a denominator. Remember to multiply both numerator and denominator by all missing factors. A next common mistake is not distributing the negative sign. When subtracting, distribute the negative to all terms in the numerator. And then canceling incorrectly. Only cancel common factors, never individual terms. So here's our key recap. You need to factor everything. Break down all denominators into prime factors. Then find the least common denominator. Then rewrite each expression by creating equivalent fractions with the least common denominator. You'll then be able to combine the numerators. So you'll be able to add or subtract the numerators, and finally simplify. You can factor and cancel when possible. So here's your challenge. Perform this operation. X plus 4 over x squared minus 4 plus 3x over x squared plus 2x. You'll need to factor the denominators first, find the least common denominator, rewrite, combine, and simplify. So you think you've got it? Please comment your answer below. So if rational expressions look scary before, they won't anymore. You now have the tools to tackle any addition or subtraction problem with confidence. Thanks for watching. Please like and subscribe. And don't forget, math success starts when you stay on the fast track.